now we're allowing ourselves decision boundaries which are any d-dimensional hyper thing, not hyperplane, hyper thing, yeah, okay. Some degree d function anyway. Okay. So, I mean, if d here is 2, then not only are we allowing ourselves boundaries with x1 squared and x2 squared and x1, x2, but because of the +1 here, there's also linear terms in x1 dash x2, and so our boundaries might also include terms in x1 and x2 as well. Right. So maybe the kernel that's most often used in practice, though, is known as the radial basis kernel. And that has a kind of, you can think of this as having a Gaussian at every point, and they're measuring how far apart they are using a Gaussian function and how the two Gaussians are interacting in some sense. So here we define a kernel like this, e to the minus gamma times the magnitude of xi minus xj all squared. And you can see this written in other ways as well. And in fact, it turns out that the corresponding phi is actually mapping. I mean, so even if you're starting with the two-dimensional data, the corresponding phi is to mapping your points into infinite dimensional space. And it's a slightly weird idea how that mapping works, but it normally gives you much more localized boundaries. And you can choose your gamma to measure how far your Gaussians are dying away. You can vary it in other ways, so you can have varying gammas at every point, and various other things. So the radial basis kernel is the most often used in practice. There are plenty of other functions which do satisfy those formal rules for looking like a kernel function, but they're much more rarely used in practice. So I'll simply end by saying that there are many algorithms that you can write down purely in terms of the dot product between data points. PCA is one. It's a kind of an exercise. So it's a useful part in many other algorithms. So you're kind of getting principal components which are no longer linear combinations, but maybe quadratic combinations or something similar. So a kernel PCA is widely used, and lots of other algorithms also have kernelized counterparts as well. Okay, so just remind you again, no lecture tomorrow, and see you hopefully next Monday.